Hello everyone. So today we'll be talking about my project Secure Online Transaction Using Face Recognition. Myself, Rajat Kumar from VelTech Institute of Science and Technology. Our project is guided by Dr.K.Meena ma'am, and my project members are Swagat Mohanty, Rajat Kumar, and Naina Mohammed A. The abstract of the project includes privacy, as we know, has become one of the major concerns in the world where billions of people produce multi billion data every day over the internet. The data that we produce is not just stored in virtual devices, it's also stored over the web. So there is a continuous exchange of data using servers and the internet. This data can be used as a biometrical based application for distinguishing and identifying people and verifying them for security purposes. One such purpose is securing online transactions that happens on the internet. The verification of an online transaction is received with the help of a one-time password known as an OTP, that is computer generated. This password is weak since it's sent over an SMS and it can be easily accessed by someone sniffing over your network. The system we made can be used for securing the transactions that are done on the internet. Research objectives: targeting the banking sector that utilizes online transactions the most, satisfying the customer by providing them with a much better and secure method of transaction over the internet, utilizing the one part of the human body, that is the face, which is unique to everyone to authenticate such transactions, making the system small in size and efficient for using them on the smartphones. Yes, we are targeting the smartphone industry, making a system that not only knows how to identify correctly but also to identify the wrong person as well. The problem statement that we came up with was related to the OTP that was mentioned before. The problem statement states that to obtain the extent to which face recognition method can be used so that the concept of OTP can be removed in order to obtain a more secure way of transaction over the internet. To determine to what extent is the face recognition method able to support the cause of online transaction and its secured nature. The network should retrain from scratch using the newly obtained data from the user's face once it is updated through the bank. This would require a lot of time, energy consumption, and impractical availability of training data of different faces to have negative examples. The introduction of the project. Financial services involve highly sensitive data and may increasingly be subjected to attacks over the network on which they are built. This system that we provide progressively discusses the introduction of face detection and recognition system for replacing the traditional one-time password method of verification during the event of an online transaction carried over the internet. It enables the end user or else the customer to seamlessly log in with their face and verify transactions or payments just by simply looking at the front camera of their smartphone. Just like all biometric systems, face recognition technology also measures and matches the unique characteristics for the purpose of identification and authentication. But here, the advantage of using face recognition is that face recognition does not require any additional hardware. The smartphones in the 21st century all come equipped with a front facing camera. The existing system, of course, has some drawbacks to which we are proposing the system. The following are the drawbacks. The existing system is just a text message with no encryption. Unauthorized access is possible by network sniffing or network phishing. A hardware limitation is very prominent. A customer's physical identity becomes useless, which is actually a unique property of each and every one of them. The system that we have proposed is based on a SCNN or a CMC like convolutional neural network trained into a low dimensional latent space shaped to maximize distances between faces of different people using contrastive loss. A given face data must look for similarities between the trained face and the input face in order to place it in a vector graph with the position corresponding to its value. If the points in the vector space are close to each other, meaning the faces are identical and hence it is true. If the points in the vector space are apart from each other, That means that the faces are not identical, that is, are of two different people, and hence it is false. Here, the proposed system uses the concept of similarities between two faces instead of finding the differences between the two faces, meaning that if the two input images are of the same person, the vector space points would be close to each other, whereas if they are of two different people, the vector space points would be far away from each other. Of course, the proposed system has some advantages. The following are the advantages. The anti spoofing capability nature of the trained model makes it safe from imposters on the internet that try to get unauthorized access to the network. The squeeze net here that we are using makes faster deployment and easy development possible. The system focuses on similarities rather than conventional differences. The real time classification of the facial features is possible. The system is highly secure and faster than the existing solution of OTP and fingerprint authentication. So here is the flowchart of transaction using the user face, that is a basic overview of what the system is. So this here is the system architecture, which has training phase and testing phase. This is the general working of the system wherein the user logs in, the detection is enabled through the front camera and the process is moved forward. This is the raw input for the RGBD database. This is the pre-processed input and the obtained training sample of the database. Notice the RGBD format. This is an example of a correct couple. This is an example of an incorrect couple. The following is the visualization using TensorBoard of the network. The statistics show that the proposed model has an accuracy level of 87.6 and a loss value of 2.85, which is far better from the above models. The future enhancements include. So coming to the coding part of the system, this is the following coding part wherein we make directories for training the dataset as well as for validating the dataset. We import certain backend APIs for using. Here we are using Keras as the backend and TensorFlow as the platform. This is the database that we are using. This is the extraction of the database. Here we create a couple. Notice how the couple gets created. Here we're defining a couple, so this is the couple that gets created for the entire database. Scrolling down, we find the definition for the wrong couple. We define the wrong couple and then we print the wrong couple. Notice how the wrong couple has been created with two different faces. We import certain APIs from Keras. We define the Euclidean distance, the fire module, the input shaping. Notice that here we can see a lot of layers, 36 to be precise, and we will be reducing these layers one after the other. Now we define the input. The input has now changed it from 36 to 2 input channels. So now we have reduced the architecture of our system to 2. Here we define the generator, which defines the printing of the training dataset. The generator defines the printing of the validation dataset. Notice face ID underscore train and face ID underscore val, which define training and validation. So here we finally create the training and we start the network crafting. These are all the parameters that we use, and this is the resultant output of training the dataset. Notice how the images are cropped and then converted into an RGBD format and then fit into the system. Thank you for watching.